Hello there, in this video I'm going to be showing you how to derive the 5 main formulas used to solve problems about particles moving in a straight line with constant acceleration. In order to do this, we need to know 5 definitions. S is going to be for displacement, that is, distance moved. U is going to be for starting, that is, initial velocity. V is going to be for final velocity. A is going to be for acceleration. And T is going to be for time. Now let's start off by deriving the first equation, that is, V is equal to U plus AT. Acceleration is change in velocity over change in time. Okay? So this means that A is equal to the final velocity minus the initial velocity over time. Okay? So this is acceleration over here. If we multiply both sides of this equation by t, we get AT is equal to V minus U. What we then do is add U to both sides of this equation. And if we do that, we end up with V is equal to U plus AT. Okay, that is, the final velocity is equal to the initial velocity plus acceleration multiplied by time. So let's move on to the second equation. That is, S is U plus V over 2 times T. Well, the distance moved, that is going to be S, is average speed multiplied by time. Now, since the average speed is the initial velocity plus the final velocity over 2, what we end up with is S, which is the distance moved, is U plus V over 2, which is the average speed multiplied by time. Now, how do we get this equation over here? Well, A is V minus U over T, and S is U plus V over 2 times T. Now watch what happens when we multiply both sides of this equation by T. We get AT is equal to V minus U. We can change this equation again. We can divide both sides of it by A. Okay? So what we get is T is equal to V minus U over A. Now what we're going to do is plug this into this S equation over here, and this will eventually give us this formula over here. So recall, S is U plus V over 2 times T, but T is V minus U over A. So what we have is S is equal to U plus V over 2 times V minus U over A. Now from here, what we're going to use is the FOIL method. That is, first, outer, inner, and last, okay, to expand these brackets over here. If we use the FOIL method, we're going to get S is equal to uv minus u squared plus v squared minus uv, and that is over 2 times a, okay? And we can get rid of these uv's over here because we have uv minus uv. And what this leaves us with is, if we multiply both sides of this equation by 2a, is 2a multiplied by s is equal to v squared minus u squared. Now, if we add u squared to both sides of this equation, what we then get is v squared is equal to u squared plus 2as, okay? And we've derived the third equation over here, okay? So that is the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times displacement. Now let's see if we can get this fourth equation over here. Recall that s is u plus v over 2 times t. And also recall that v is equal to u plus at. If this is the case, we can transform this formula over here and get this over here. So what we're doing is plugging this v into this v over here in the s equation, okay? So we get this up here. This up here is going to give us, in brackets, 2u plus at over 2, okay, multiplied by t. And these 2's over here cancel each other out. So what we have in brackets is u plus half at, okay, multiplied by t. And this gives us, for s, ut plus half at squared. This means that s, which is displacement, is equal to starting velocity times time plus half times acceleration times time squared. Now let's deal with the fifth and final equation over here. Recall that s is ut plus half at squared. Also recall that v is u plus at, therefore u is v minus at. If we plug this u over here into this, we should get this equation up here. So let's plug this u over here into this u up here. What we get is s is v minus at times t plus half at squared. Now let's expand on this. So from here we get vt minus at squared plus half at squared. This is the same as vt minus 2 over 2, which is 1, at squared plus half at squared, okay? So these two over here are equivalent. And that leaves us with, because a half minus 1 is minus a half vt minus half at squared, okay, which is s. So this final equation over here is displacement is equal to final velocity times time minus half times acceleration times time squared, okay? And this is the fifth and final equation that we had to derive. You're going to encounter these equations in A-level mechanics, mathematics, okay? These are the formulas you need to know for solving problems about particles moving in a straight line with constant acceleration. If you like these kinds of workings and you want more of this content, subscribe to this YouTube channel. Also, if you need assistance with your algebra, visit mathematics.proofs on Instagram. As always, thanks for watching, and I'll see you next time.